This lesson will be on radical inequalities. We're going to look at how we use the graphs of radical inequalities on a number line to help us solve radical inequalities with just one variable. So just notice the difference here. We only have x's involved, not x's and y's. So when we use a graph on this, it's just going to be on a number line for x to test it out. So here are our steps for doing it. The first big idea here is that we're going to look at finding the boundaries for possible shading regions for the inequality, and we're going to test those regions to find our solution. So steps for solving radical inequalities by testing regions. First of all, if it's an even index, you need to have the extra step of making sure you check to see where your radicand is greater than or equal to 0. You can't have a negative radicand in the real numbers on a real number line for these inequalities. So you first of all just test to see when the radicand is greater than or equal to 0, and then you go ahead and make the inequality an equation, solve the equation like we've been doing. That will help us find the regions to test values, and then use these two steps to test different regions to see where we shade. So let's try this first example. The first step for this is that we're going to take and we're going to do 2x plus 2. We're going to set that greater than or equal to 0 because it's an even index, it's a square root, so we're going to make sure that our radicand is not negative. Subtract 2 from both sides, divide by 2, and I get x is greater than or equal to -1. So let's go ahead and put a number line here. And so if here's 0, here's -1, I make sure I recognize that I'm not going to go over on the left side of -1 because of my radicand. All right, now let's go ahead and solve the equation. So I'm going to set this equation up. Square root of 2x plus 2 plus the 1 outside the square root is greater than or equal to 5. Subtract 1 from both sides. Okay, so we're going to go ahead and let's make this an equal sign. Okay, so equal to 5. So square root of 2x plus 2 is equal to 4 when we subtract 1 from both sides. Square both sides, you get 2x plus 2 is equal to 16. Subtract 2, 2x is equal to 14. X is equal to 7. So 7 is a boundary point for that equation. So let's go out to 7. 1, 2, 3, 4, 5, 6, and 7. Okay, now on that point, because it's an or equal to, I'm going to put a solid dot there. Okay, now over here, I would put, notice a solid dot on -1, but notice if I'm not on the left of 7, I wouldn't include that. So this just gives me regions. I know for sure it's not to the left of -1. I'm going to test in between -1 and 7, and then I'll test to see on the other side of 7. So let's test a region. Let's put in, for instance, x equals 0 and test it. So if I put in 0 into my original equation, I get the square root of 0 plus 2 is 2, plus 1. Is that greater than or equal to 5? Well, if you don't have an intuitive sense of what the square root of 2 is, we can go to a calculator and we can go ahead and put in, for this, we're going to put in the square root of 2, and then we're going to add 1 to it. Is this, does this compare to 5? Well, notice it's not greater than or equal to 5, it's less than it. So this is a false statement, so this would be a no. So this region does not get included between the two numbers. Now I got to be careful if I'm thinking about number lines, then I want to be cautious that if I were graphing the answer that I'd have to erase that solid dot. I'm just looking for the inequality at this point. Now let's test a point to the right of 7. For instance, let's try x equals 8. Let's put that into the square root. Okay, we got the square root of 16 plus 2 is going to be equal to 18. Is the square root of 18 plus 1, is that greater than or equal to 5? We're asking that question. And again, you could maybe do that mentally to see that that will be correct, but let's check it out. So second square root of 18 Get out of there, and then plus 1, is this greater than or equal to 5? And it is, it's greater than it. So this one is a yes. So what I'm going to do is I'm going to have everything on this side of 7 be my solution. So I'm going to have x is greater than or equal to 7 as my solution for this inequality. So now that we see those steps, we're going to check radicands. If my index is even, I'm then going to solve the equation to see boundaries to test regions. Let's try the next one. I again have an even index, it's a square root. So I'm going to take my 4x minus 4 and set it greater than or equal to 0. So 4x is greater than or equal to 4, and then x will be greater than or equal to 1 on this case. Now I'm going to go ahead and solve the equation. So square root of 4x minus 4 minus 2 is, we're going to set equal to 4. And then we're going to solve it. So here I add 2 to both sides. Square root of 4x minus 4 is equal to 6. Square both sides, you get 4x minus 4 is equal to 36. I'm going to solve the rest of that equation, add 4 to both sides, and you get 40. Divide by 4, you get x equal to 10. Now we're going to go ahead and test our regions here. With this one, I'm going to, as I draw a number line to see what my regions are, I'm going to start over here. If I have 0, here's 1. I'm going to put a solid dot on 1. Now, it might not be part of my solution. It's just telling me that's the start of one of the regions. And we go out to 10. Okay, here's 10. And so I'm going to, for this one, I'm going to put an open dot on it. So open dot here because it's not or equal to. So again, remember the radicand is greater than or equal to 0, so that's a solid dot, but the inequality itself has a less than, so the 10, the thing I solved the equation for, gets an open dot. Now let's test the regions. Remember, this region I don't even have to test because this is telling me I have to be greater than or equal to 1 for my radicand. Let's test between them. Let's put in, for instance, we'll put in x equals 5 between these two. So if you put in 5, you get the square root of 4x times 5 is going to be 20 minus 4 is 16. Okay, and then we're going to have minus 2. Is that less than 4? Well, let's check this out. Square root of 16 is equal to 4 minus 2 less than 4, and that's a yes. Okay, so I'm going to shade between these two regions, in this region between these two numbers. Let's check, there's some times that you'll get more than one region. Let's check x equals 11 on this one. Okay, if I put in 11, I get square root of 44 minus 4 is equal to just 40. And then minus 2, is that less than 4? Okay, let's test that out. So let's go to our calculator. Square root of 40. Get out of the square root, then subtract 2. And I get for that a 4.3. Is 4.3 less than 4? That's a no, so I don't shade on that side. So my answer is going to be that my x has to be less than 10, greater than or equal to 1. Remember when we do the between notation that we have to have the inequalities facing the same way. This means between. If you read it from the x is less than 10 for this one. X is greater than or equal to 1 if you read it from the x for this one. So there's my inequality for it. If you do it in notation for open and close notation, you'd put a 1, comma 10 and an open parentheses on the 10. Let's try the next one. This is a cube root. We don't have to do step 1 for a cube root because I can take the cube root of a negative. That's all right. So I can use my domain as including negatives here. So you can go to step 2 and just make it the cube root of x plus 1 plus 4 equal to 0. Subtract 4 from both sides, so the cube root of x plus 1, is that less than or equal to -4? Then I go ahead and cube both sides. So if I cube both sides, I'm going to get x plus 1. If you cube -4, let's make this an equal sign here. So if you cube -4, you get a -64. Subtract 1 and you get x equal to -65 when you subtract that. So now I only have one boundary point. So if I go to a number line, just to check, this number line is just to help us with a visual of what points we're checking. So if you go out to, if I go by let's go tens, you get 10, 20, 30, 40, 50, 60. Here's -65. So I'm gonna have on this one a closed dot on -65 for this, okay? And now I'm going to test to the left and to the right of it. So if I test, for instance, x equal to -70, which is to the left of it, put that in here. Cube root of -70 plus 1 is -69, plus 4 is that less than or equal to 0. Let's test it out on our calculator. So we do our cube root. So let's go to math. Go down to the cube root, and I'm going to do -69 here, and then get out of the cube root, add 4, and is that going to be less than or equal to 0? Okay, it is less than 0, it's a negative, so I am going to go out in this direction. This is a yes. Let's test a number to the right. You can pick any number to the right. I could pick -60 if I wanted to, or I could just pick x equals 0. So put that in, I get the cube root of 1 plus 4. Is that going to be less than or equal to 0? Well, cube root of 1 is 1 plus 5, less than or equal to 0, that's a no. So this is my only answer. X is less than or equal to -65 for my answer. And let's look at example 4. This one looks a little more complicated, and it is. The key to recognize for this is that there's two different radicands. It lists 3, but 2 of them are the same. So when I test, I got to make sure to set up my boundaries. I'm going to say that x has to be greater than or equal to 0 for this one. That's my first radicand. This one, 2 minus x has to be greater than or equal to 0. So I'm going to put up here just radicands, just so we know that that's what we're checking first in our first statement, because these are square roots. So subtract 2 from both sides, multiply by -1, that reverses my inequality. Remember, multiplying or dividing by a negative will reverse the inequality symbol. So now I know that x has to be greater than or equal to 0, x has to be less than or equal to 2, so that gives me a very small range of numbers to be checking here. All right, so I'm going to just draw that out on my number line just so I remember. If I've got 0 here, here's 2, I'm going to put a closed dot on this one, I'm going to put a closed dot on this one, okay, and now I'm going to go ahead and solve the equation. So got to make sure you can solve the equation. The square root of x plus the square root of 2 minus x is equal to 3 square roots of x. Let's go ahead and subtract 1 square root of x from both sides. Get those together. That gives me 2 square roots of x. 3 square roots of x minus 1 square root of x will give me just the 2 square roots of x. Now I can square both sides. It's not as hard as it looked, because now I've got both radicals here on opposite sides. So if I square this side, I get 2 minus x equal to square the 2 and you get a 4. Square the square root of x, you get an x. Add x to both sides, you get 2 equal to 5x. Divide by 5 and you get x equal to 2/5, which is the same as 0.4. I'm going to use just 0.4 just as a to help me on this graph. So if I go up here, if this is 1, 0.4 is right about there. I'm gonna put an or equal to, a solid dot on it, just to emphasize where my regions are. So I'm not gonna go on this side of 0, because this is telling me it has to be greater than or equal to 0. I'm not going on this side of 2, because this tells me I've got to be less than or equal to 2. So I just have these two regions to check. So let's check over here. Let's check, I'm going to put my check over here. X is equal to, let's put in 0.2, which is right between 0 and 0.4. So let's try it out. Is the square root of 0.2 plus the square root of 2 minus 0.2 is equal to 1.8. Is that less than or equal to 3 times the square root of 0.2? Let's check it out. Let's put it on a calculator. Okay, so I'm going to have here the square root of 0.2, get out the square root, plus the square root of 1.8. Okay, what do I get for that one? And then for the other one, I get the square root of 0.2. Is this number less than or equal to that number? Okay, that number less than or equal to that number. And the answer is no, it doesn't work. This number is greater than, this side is greater than that side. Okay, oh, I gotta do 3 times it, so let's check that out, sorry. Let's do 3 times the square root of 0.2. Okay, but again, is this number less than or equal to this number? Okay, 1.7, 1.8 basically is not less than 1.3, so this region does not work, okay? So this would be a no, and I don't get this region right here. So it's likely we're gonna get this one, but let's check a number. I'm gonna put in x equal to 1. It's a nice number for that. So square root of 1 plus the square root of 2 minus 1 is just 1. Is that less than or equal to 3 times the square root of 1? So this turns out to be quite nice. We can do it without a calculator. 1 plus 1 is 2. Is that less than or equal to 3 times 1? And that's just 3. The answer is yes, this one works. So I'm going to shade between these 2 points. So my answer is x has to be less than or equal to 2, and it has to be greater than or equal to 0.4, so between 0.4 and 2. So follow your steps. Apply what you know about radical equations, but you have to remember with the inequalities, first of all, test when your radicand has to be greater than or equal to 0 for an even index, and then use the equations to set up regions, test the regions to see if they work in the inequality, and then find your final inequality answer.